Unit 2, we've got 15 total sections of this unit. So today is kind of reliant on the calculator part of it. We are going to do the thing that we've done before where we put some data into the lists and spreadsheets on the calculator. We're going to run a logarithmic regression. But before we do that, there's a little bit of work to do by hand that I need to show you for your upcoming free response on the test next week. Basically, here is a graph. Here's some data. And that data appears to be logarithmic. A lot of real-world scenarios follow a log pattern, like how we measure earthquakes, sound, acidity, and a lot of other contexts. So we need to create logarithmic models for data sometimes in the real world. So you'll learn how to do that today. In this box here, really the most pertinent information that we're going to use on example 1 is a logarithmic function model has the form y equals a plus b natural log x, or y equals a plus b common log x, where a and b are constants. So what you might see in a free response setting, and you will need your calculator for this, is selected values of the log function are given above, where L of x equals a plus b natural log of x. Use the given data to write two equations that can be used to find the values for a and b, and find a and b. Okay, so we're not going to type this into the list and spreadsheets because the very first directive here is to write two equations that could be used to find a and b. Can you come back at the end? So we have to write two equations. Well, in your table here, we've got inputs and outputs to plug in. So we're going to take these two things that I've highlighted up here, and in this particular problem, we're going to use the natural log. Okay, we're going to plug in our inputs and outputs in for x and y, and we're going to create two equations that will then allow us to solve for a and b. We've done this before, which has been a while. So the very first equation I can write with that ordered pair 2, 3 is 3 equals a plus b natural log 2. I want you to notice that I plugged in x and y for that first ordered pair. There's one equation. And now I'm sure you know how to set up the other equation. The other equation is going to be 7 is the output equals a plus b. How do I know to use natural log instead of common log? Well, it told me in the problem that this can be modeled by a plus b natural log x. And the input there would be 5, 7. Those are the two equations that we're going to use to solve, because you might have a free response question that says solve for a and b and show the work that led you to that answer. So you can't just rely on the calculator to give you your a and b values and just plop them on the page and circle them. So back in Algebra 2, you learned a couple of different ways of solving a system of equations. You can use the substitution method. You can use elimination. I'm going to show you how to use elimination and that it actually works in a logarithmic setting. It's kind of cool. So why don't you just make a little note. I'm showing you the elimination method. If you wanted to give substitution a try, you could. It will all work out to be the same. Elimination is where we stack the two equations and we try to get some stuff to cancel out. I like to put, like, if I'm choosing the red or the green to put on top, I kind of like to put the larger number, like 7. I like to put that one on top. So I'm going to do this. I'm going to do 7 equals a plus b times natural log of 5. And And I'm going to put the red equation under it, but I'm going to change all the signs. You're going to tell me why I'm doing this. So I'm taking that 3 equals a plus b ln 2, and I'm going to change it to negative 3 equals negative a minus b times natural log of 2. Why did I do that? What is now eliminated? What cancels out? The a's are now eliminated. So I took the red equation, I changed the sign of everything, which means mathematically I didn't change its value. I just changed the way it looks, so that the a's would cancel out. So what I have here is 7 minus 3, so that's 4, equals, and then I'm going to write this as b natural log of 5 minus b natural log of 2. There are a couple of different ways you can go about doing this, okay? If you're a student who remembers the b in front can move back to be the exponent, you can do it that way. But I'm just going to show you using some algebra skills that all of you have, how you can go about this. What I notice is over here, these logarithms, these terms, they both have a b in front. So I'm going to factor out that b. I'm going to factor out that b value. That will leave me with natural log of 5 minus natural log of 2. You give me some guidance and tell me what you would like to do from here. Using log properties. Yeah. Yes, so we can condense this into a single logarithm using the quotient property that says if you have two logs being subtracted, you can condense them into one. So that's going to become 4 equals b times natural log of just 5 halves. And we're almost done. What's the only thing I need to do to get b alone? I've almost solved for b. Divide, because it's being multiplied, so to get rid of multiplication and divide, I'm going to divide both sides by natural log of 5 halves. So here is what b is, 4 over natural log of 5 halves. That looks like a H. Let me fix that. Pick up your calculator, figure out what 4 divided by natural log of 5 halves is. Four over natural log of 5 halves on the AP exam. If we're going to write a decimal value, we need to take it out to that third position. So 4.365. B is approximately 4.365. Before we solve for A, I just want to recap what we just did. We used the elimination method. We factored out the B. We condensed this in parentheses to a single logarithm, and then we just had to divide by that to get B by itself. And from there, we have to use a calculator to get the decimal value. Okay, so now we're going to get to solve for A. And I don't know. I mean, there's tons of different ways you can do it. I kind of want to go this route. I took that red equation and I just kind of manipulated it where A was by itself. So if I can just figure out what 3 minus B times natural log of 2 is, then I'll have my answer. This is also going to be an approximation because we're plugging in a decimal value. 3 minus, and then if you're really savvy with your technology here, you can just go up here and highlight that original answer we got for B, and we can paste it down, and look, it doesn't truncate it as much. So we can get a way more exact answer than if we type in 4.365. Again, how I did that is I just arrowed up, so it was highlighted, and hit enter, and it pasted down a way less rounded value for B. Natural log of 2, and it's going to do all the number crunching for us. So A is going to be approximately negative 0.026. We're going to work another one of these at the end of the notes today that's easier than this one. So I would say this is probably as involved as the whole writing 2 log equations and using elimination gets. This is as involved as it gets. Believe it or not, some of these don't even require a calculator. You might be able to see that in notes today. Okay, so go to the back. We're going to do something really easy. You've seen this on a couple of different recent tests. You have all of this data laid out, and this is showing you how many members are in the congregation of a church related to the average salary in thousands of what a pastor makes at that church. That's what the graph at the beginning of the notes was showing. A says use the regression capabilities of your graphing calculator to find a logarithmic function model. You have to read closely because there are tons of different regressions that your calculator can do. This time, it wants you to run a regression model where P represents the church size and S is the average pastor salary in thousands of dollars. Okay. So I hear some of you already typing away. You're going to open up a new list in spreadsheets. Title your columns X and Y. Carefully enter in the data. It's not a race. And then when you have it, just kind of glance over, make sure everything looks good. Now you're going to run a logarithmic regression. Menu, statistics, stat calculations. You're going to have to arrow all the way down to B, logarithmic regression. As usual, you'll have to tell your calculator what you titled the X and Y columns. And then you may have to arrow up to be able to see those A and B values there. Does anybody need me to repeat any of that? Are we all comfortable with what just happened? Okay. A on your calculator screen should be negative 91.542 and B should be 29.9088. So what we're going to do is we're going to take that and we're going to plop those into this model. S of P equals, okay, A is negative 91.542. Now I'm going to put dot, 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 because technically that calculator screen has rounded that value. Plus, B is 29.9088, and I'm going to put dot, 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 LNP. The dot, dot, dots just indicate that I know my calculator truncated the decimal. It doesn't really chop off right there. So, I don't really think so. I think that if you didn't have those there, part B would be enough proof that you didn't round. Because what we're about to do, instead of plugging into, this, is we're going to do the control T thing. So I don't really think we need the dot dot dots. If this was like a multiple part response, they would know that you didn't round by your answer on part B. So using the model found in part A, what is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people? So what we need to do is we need to hit Control T. Everything is stored in our F1. And then instead of arrowing down to 500, edit your table settings to start at 500. You should know how to do that. Menu, table, edit table settings, start at 500. Now, the way we write this is going to be kind of weird, but we're going to write 94.3295 thousand. We got 94.3295. If you just put the word thousand on there, that's good. If you're a person where, that just really doesn't make sense to you and you want to change it into having the comma, that's also fine. But I would just leave it alone. Because if you go one extra step, there's a chance you might mess up. For $94-ish thousand. Okay. Now I'm going to take you through a problem. The very last example is really closely aligned with what you see in your free response. The most common and preferred method to measure sound intensity levels is in decibels. The sound intensity level, and there's the symbol for that, I think it's there, in decibels of a sound wave having intensity I in watts per meter squared is modeled by this function. I have no idea what I just read. I just know what the symbols stand for, okay? I can also tell that I is going to be the input, and the output will be the decibels. A and B are constants. The sound of noisy traffic has this intensity and corresponds to 70 decibels. They just gave me an ordered pair. 70, comma, 10 to the negative fifth power. Input, comma, output. Excuse A says use the given data to write two equations that could be used to find the values for constants A and B. So we are going to do exactly what we did on example 1, where it gave us a table with two ordered pairs and we wrote equations. We're just going to use the information from the paragraph. So output is 70 decibels when the intensity, so A plus B log, and then the intensity is 10 to the negative fifth. Now look how I write that. I don't really want to write the 1 times 10 to the negative fifth. There's a reason I'm just going to write 10 to the negative fifth. And then the second ordered pair, the output is 120 decibels of a loud concert that has an intensity of 1. Now, you can set this up for elimination. You can do the same thing you did on example 1, and you can get your answer. But if you know how to evaluate logs, this problem actually becomes a lot easier. So I'm going to lightly circle something. Log of 10 to the negative fifth. You should know what numeric value that equals. What is log base 10 of 10 to the negative fifth power? Yeah, that's that rule I keep kind of mentioning off to the side where I say, remember, like log base A of A to the B power is B. That's exactly what we have in front of us here is log base 10 of 10 to the negative fifth. So what I circled there is really just negative 5. So in a second I can rewrite this as negative 5b. Okay, now wait, I can also do something in this situation. You should know what log base 10 of 1 is. How is it 0? How do you know that? That's correct. 10 to the 0 power gives you 1. Log base smiley face of 1 is 0. Anytime your argument is 1, then evaluating that logarithm is going to give you 0. If you haven't noticed by now. And that's why you have a lot of practice on that at the beginning of Chapter 13. So check this out. I kind of just made the logarithm situation disappear. I really have 70 equals A minus 5B, and 120 equals, well, 0 times B is going to just be what? 0. Oh my gosh, what is A? We already solved for A. Now how easy is it going to be to solve for B? Very, very easy. Yes. Right here, log base 10 of 10 to the negative fifth is negative 5, and that's being multiplied by B. So negative 5B. Any other questions? So, as a mathematician, I prefer this way. I don't want to do elimination of logs and all that business if I don't have to. So if A is 120, I've already kind of started the process for down here. A is 120. Bless you. What are you getting for B? You should be getting 10, because right here, if you plug in 120 for A, then on the calculator you're just going to do 70 minus 120 divided by negative 5, and you get 10. Okay, awesome. Well, let's answer part C. The human eardrum can burst when sounds reach an intensity of 10 to the fourth. According to this model that we just found above, what's the predicted number of decimals required to burst a human eardrum? Let's take this equation up here that has our inputs as intensity and our outputs as decimal, and let's go ahead and apply what we just figured out A and B are. So I'm going to say beta of intensity equals A, which was 120, plus B, which is 10, log of I. I figured out what A and B were. I plopped them back into the equation. Now I can answer this question. How many decimals are required to burst an eardrum? And that's 10 to the fourth on the intensity level. So I'm plugging in 10 to the fourth for I. What's log base 10 of 10 to the fourth? 4. So this really ends up being like 10 times 4. You kind of saw that on your last quiz, the one where you were all like, "Can you do this one without a calculator?" You have to be able to evaluate logs. So this just says 120 plus 40. Go ahead and put your answer in context. Put some units to that. What would our units be? What's the output units? decibels. I promise you, on the AP exam in May, you will have a free response question where you have to take information, set up a system of equations, solve for A and B, and then answer a question based on the model that you created. I mean, they told us this summer you will have a free response question in exactly that format. Okay?